Speak in English because my Korean is very bad. I'm going to talk about a little bit about the Korean voice search development. Here we go. So what were our goals? We wanted to build a large vocabulary Korean speech recognizer. We have built in English a recognizer that is used in America, in England, in New Zealand, in Australia. And then we built a Mandarin recognizer, and at the same time we built the Japanese recognizer. And after that, we started with the Korean recognizer. And just last week, we launched in 4 more languages, in German, French, Spanish, and Italian. But those were actually developed after Korean. So what we wanted was, we want to use it for voice search, meaning you can, instead of typing, you can just say something, just as Heinrich just showed us. We wanted a fast response time. We wanted it server-based because the information we're looking for is on the server anyhow. You want World Cup results or something like that. It comes from the server. One more sentence. And we wanted it with good accuracy. So I have one slide about the technology. Most speech recognizers today in any language are more or less the same. They're based on a set of statistical models. The first one is called an acoustic model, which just represents the basic sounds of Korean, in this case. And this is trained on recorded speech with transcriptions. In this case, more than 100 hours of recorded speech from Korean. And the language model is trained on millions of search queries that people have typed into the normal Korean web search engine. So finally, we have the dictionary, which represents the mapping from words to pronunciations. And in our case, that is mostly done by rules. And I will talk about this on the next slide a little bit more. Okay, so where is the cloud used? When we talk about the cloud, we mean just our many machines. Google has many hundred thousands of machines that are used. So the cloud helps us to train the models fast and efficiently, to run lots of experiments, and to access all necessary information quickly, like the recognition result is computed fast, and also alternative results are shown. And also the search result itself, the maps and the links, after the speech recognition result is displayed. So what were some of the challenges that we had with Korean? So first of all, Korean speech recognition is difficult, more difficult than some other languages. And there are many reasons, but one of them is that there are 10,000 or more than 10,000 basic symbols. If we call the Hangul and ASCII, the normal Unicode Hangul characters, if you count them as one character, that I talked about before, was hard to build because there's very little information publicly available on the internet. We use altogether more than 200,000 words, which can be recognized in any order. So when we generate the pronunciations for the dictionary, luckily Korean was not so hard because it has one of the most elegant alphabets in the world. So when we looked at the queries that people type in, we saw that people don't only type Korean, they also type English in Korea, and they mix English and Korean in the same query. NCIS Season 6 or NCIS Season 6, it means the same, but it has 2 different answers. And this is just one of the examples that doesn't happen like this in other languages. Finally, there are many exceptions, like spelled letters English digits and numbers. So some examples here is Samsung TV. It's not Samsung. Okay, it's MP3 or MP3. It's not MP3. It's KBS 2, not KBSE. And it's 2010 and not 2010 or 2010. Okay, so what is easy and hard to recognize? Because we train on web queries, what is easy to recognize are often used web queries, like Daegu Shinwon, Samsung TV, Busan Bibimbap, Tokyo Mechi. Those are some of the queries that I tried in the beginning, and I don't speak Korean, but it's still got it right. To say, these are just examples, of course. Common products, names, shops, locations, everything that is common will be recognized. So what is hard to recognize are very short words, which are just one syllable, for example, or rare queries, like rare first names and similar. So finally, the quality is okay already, but it will get even better with time when we retrain the models. That will take between 3 and 6 months and maybe more, but we will retrain many times and the quality will get better. So finally, what do we see in the future? For recognition, it will get significantly better over time, as I just said. And it will also become more robust against noise. Search will also be available on more clients, as Haimin already explained, on the iPhone, maybe on all the other Android phones. There are more clients we are thinking about, so we'll see what we see there. Finally, besides for search, we want to use speech input wherever it makes sense for the users. So meaning any text field on your mobile phone. Speech, we believe that speech is going to be an important input modality on mobile devices, and it's not going to go away. It's going to become stronger every month, every year.